Hey y'all, for this lesson we are going to need two things. We're number one going to need your collision theory notes, either from the paper copy you picked up before spring break or the downloaded ones that are right above this video on this page, and you will need a writing utensil. Today's lesson is going to be on what we call collision theory. What we're going to try to be doing is explaining why is it that the reaction rate changes when we change the concentration or change the temperature. And so collision theory is our sort of explanation for why increasing the temperature increases the reaction rate and increasing the concentration increases the reaction rate. So basically, collision theory says that the rate of a chemical reaction is determined by two things. Number one, the number of collisions between reactant molecules. So if we have two things that are going to react with each other, they're two molecules, they have to run into each other. They have to collide with one another in order to react. If they just, it's a little bit like we think of with a collision in general, is that things have to hit in order to collide. They can't react unless they hit, unless they collide. So that's our first principle. And the second thing that matters according to collision theory is that the rate of a chemical reaction is determined by the energy of the reactant molecules. And so as we change how much energy, how much kinetic energy those molecules have, that will change how quickly that reaction happens. And recall that the rate of a chemical reaction is how quickly that reaction occurs. And so we're going to see that we can explain temperature and concentration's effect on reaction rate by using just these two ideas. So the first point of collision theory says the rate of a reaction is partly determined by the number of particle collisions. So three steps, three things to remember in terms of understanding collision theory. Number one, for a reaction to occur, the reactant particles must collide. Common sense. If the reactant particles don't touch each other, they can't react with each other. Number two, the more collisions occur, the better the chance the particles will react. So step two, it's not always the case that collisions result in reactions. Sometimes the particles just bounce off each other. But the more times that they run into each other, the better chance they're going to react. The fewer times they run into each other or the fewer times they collide, the lower the number of reactions in a certain amount of time are going to be. And then number three, any change that makes more collisions will increase the reaction rate. So whatever we do to this, if it results in more collisions between particles, the reaction rate will go up. So we have two situations here. Situation one, we have these particles that are going around here. So blue and green are going to try to react. And so situation two, also blue and green are going to try to react. And so in the next question, I want you to choose in which of these two situations would particles collide more often. So I think we'll sort of agree here. It definitely is going to be situation two. Those particles are very, very close to each other. They're all packed into a very small space. And if they're packed into a small space, then they're going to simply run into each other more often. It's a little bit like having 20 people, and if those 20 people are out wandering around blindfolded on a football field, they're going to be spread out. They're not going to run into each other very often. But if we took those same 20 people and had them wander around blindfolded on a basketball court, because of the fact they're closer to each other, more people will just randomly run into each other. And certainly if we pack those 20 people into a closet, they would be running into each other like constantly because they're all so very close to each other. So this is an issue of concentration. Remember, concentration is how much of a substance is packed into a space. If it's highly concentrated, it means the particles are all in a very small space. If it's low concentration, then it means they're more spread out. And so when the concentration of the reactants increase, the reaction rate should increase because when the concentration is higher, the particles are closer. If the particles are closer, they'll collide more often. If the particles collide more often, the reaction rate increases. Remember, that was what collision theory says. Therefore, if the concentration increases, the reaction rate increases. We can now explain why increasing concentration increases reaction rate. If I pack my particles close together, the concentration's higher, then they're going to collide more often. If they collide more often, they're more likely to react when they collide, and so the reaction rate increases. And so increasing concentration increases reaction rate. Decreasing concentration does the opposite. Concentration is lower, the particles are farther apart. The particles are farther apart, they'll collide less often. If the particles collide less often, the reaction rate decreases. Therefore, if the concentration decreases, the reaction rate decreases. We can do it both ways. Let's look at temperature. Remember, temperature is a measure of the average kinetic energy of the particles. It tells you basically how fast they're moving. Hotter substances, higher temperature, means on average the particles are moving faster than the particles of the same substance at a lower temperature. So, we know when we increase the temperature, the reaction rate increases. So, when the temperature is higher, we know the particles move faster. If the particles move faster, they'll collide more often. If the particles collide more often, the reaction rate increases. Therefore, if the temperature increases, the reaction rate increases. So, same logic we did with concentration, it's just now they're moving faster, they're going to collide more often because they're moving faster. If we have the 20 people on a basketball court, if they're moving very, very slowly, they're not going to collide very often. But if they're running full blast, they're going to run into each other much more often, and they're more likely to, quote-unquote, react as they run into each other. The second point of collision theory says that the rate of a reaction is partly determined by the energy of the particle collisions. So, number one, for a reaction to occur, the reactant particles have to have enough kinetic energy to break the original chemical bonds. Remember that to start a reaction, we have to break old bonds. And if the particles hit so slowly that they don't have enough energy to break those bonds, no reaction happens. But if they hit extremely quickly, then they have enough energy to break those bonds, and so the reaction will happen or can happen. So the reactant particles must have enough kinetic energy to break the original bonds. 2, the more kinetic energy the particles have, the better the chance they will react, because there's a better chance they'll have enough energy to break the bonds. And so any change that results in the particles having more kinetic energy will increase the reaction rate. Here's why. The more kinetic energy the particles have, the more likely they are to get up over this sort of activation energy hump. And so, we already said that when we go to that activated complex that's in the middle, that since we've broken bonds but haven't formed new bonds, the chemical energy is always at its highest. So if I basically have particles that only have a very small kinetic energy, they have a low temperature, that would be like starting right here. Our total energy is not way up here, it's now down here. They wouldn't have enough energy to be able to get up over that hump. Another way to think about it is, imagine I have a basketball down here and I roll it to the right. If I roll it slowly, it's not going to have enough energy to get up over that hump. It'll go up a little bit and it'll come back. It stays as a reactant. But the faster I roll it, the more likely it is to be able to get up over that hump and get down to become the new substance down here. And so when you increase the temperature, you're making the particles move faster, which makes it more likely they have enough energy able to break the bonds to get up over that activation energy hump and then have that reaction actually occur. So let's go through the logic with temperature. So when the temperature is higher, the particles move faster. That's what temperature is. If the particles move faster, they have more kinetic energy. If the particles have more kinetic energy, they're more likely to react because they're able to get up over the activation energy hump and break the bonds. If they're more likely to react, the reaction rate increases. So as a conclusion, therefore, if the temperature increases, the reaction rate increases. Make sure you do include all 5 steps on your notes. So to summarize here, I want you to note that there are 2 different reasons temperature affects the reaction rate. If you increase the temperature, the particles are moving faster, which means there are more collisions, which increase the reaction rate, and it means there are higher energy collisions because the particles have more kinetic energy. If you're ever trying to explain why temperature affects the reaction rate using collision theory, you have to talk about both of these. You can't simply say more collisions, you can't simply say higher energy collisions. Higher temperature means more collisions and higher energy collisions, and both of those are going to make it more likely for the particles to react. On the other hand, concentration is only affected by one reason. There's only one reason, according to collision theory, why concentration affects the reaction rate. Higher concentration means the particles are closer, and therefore there means there are more collisions between them. Concentration does not affect energy. You could have highly concentrated and low energy, highly concentrated and high energy. Only higher concentration means the particles are closer, and so there are more collisions. But for temperature, moving faster means more collisions and means the collisions will be higher energy, and so they're more likely to react.